something interesting. I don't know if it's something that will have a long story, if I may say. Because it's like, I think it's something very much connected with the world. And more connected to world than notion. So there is a word anomaly, and people are doing something around this word. Okay. If this really corresponds to something, how to say, very important, fundamental, we don't know. In philosophy of science, yesterday, people were talking about Thomas Kuhn, a guy who became famous using this word paradigm. So something like that also, because paradigm, it's a word. No? Can we say that there is really something corresponding, important notion corresponding to that? And it was very famous during some times. I think, I'm not sure that in the future people will remember that. It's a question of some sort of timing and way of speaking and so on. But I think what is important, and I would like to... Okay. Well, what I want to say is that when we are doing philosophy of science, we have to think about the connection between this philosophy and science, if there is any connection. Now, if we look at, for example, if we look at this famous book by Thomas Kuhn, I think this book had absolutely no influence about for the development of science. It became famous among some people, but now if you think about science, if this book had not existed, science would be the same. It didn't promote anything which was important for the development of science. I think that's important to think about that. Now, at the same time, I was studying many years ago. I was studying philosophy of physics. Yeah, good teacher who was a physicist, Bernard d'Espagna. This is also something else. His research during his life was directed by some philosophical question. So we have to. It's good to know also that there are some scientists. I'm talking about, for example, in physics. There are scientists who really are philosophers. And most of the time, they are not so much recognized by the philosophy of science. I will give you another example. Bernard d'Espagna, very famous physicist. He wrote more than 10 books about philosophy of science. I have no idea if people at the university are studying this book. When I was in Paris, he was teaching in the philosophy program of graduation.
Oh, excuse me, we can hear you. We cannot hear you. No, we cannot hear you. No, no, Jean-Yves, we cannot hear you. No sound at all.
Philosophy about philosophy of physics.
Okay, we can hear you. Okay, yes.
Turn off. Turn off. Now it's working.
Yes.
Can you hear me? Okay,
Yes, very nice. Thank you.
So you didn't hear me at the beginning of my talk. No problem. Okay. Yeah, and I was saying that I think what is important is
one more time. We cannot hear you.
That should be great. Now you can hear?
now you can hear.
Yes. Very clear.
Okay, so very clear. So
Okay, now we cannot hear you one more time. When you put your microphone in the
you can hear
okay,
me?
yes.
I got it. So I was saying that, well, it's important in philosophy of science.
The microphone is off.
Try this. Yeah, it turned off alone. It was not you.
What about that? Is this working?
Yes.
Now you can. Okay. I will speak like that. And then I was saying, well, in philosophy of science, I think it's very important to have a really direct connection between philosophy and science. So I was talking about Bernard d'Espagna because I was studying with him in Paris, and when I did this work, I was not interested to read some books by philosophers of science. What was I was doing? I mean, I was interested in the question of the question of objective reality that was challenged by modern physics. So, well, what I did, I just go and read the books by Heisenberg, for example, very good philosopher, by the way. And it's surprising that people who are doing philosophy of science, most of them, they never have read the book of Heisenberg. And Heisenberg, he was really a very famous physicist. At the same time, he knew a lot about philosophy. He was able to read Plato in Greek, and he wrote some very nice book about the philosophy of physics. At least 2 or 3 books I read by him. Very easy to read. He was way of writing, which was very clear, and he knew the topic. I mean, because Heisenberg is one of the most famous physicists of the 20th century. So, yeah, I think it's important to have this connection. So I was saying that because, for example, I was talking about Kuhn. Now we are talking about anomaly and so on. Well, we have to see if this is really if we have a connection with the practice of science, research of science. So in my case, I am a logician, and if I am doing I think in the same way as Heisenberg, when you are a scientist, if you want to really go ahead to develop science, you need to be also a philosopher, because you have to ask the fundamental question about the way that the way you are doing research, how it works, and so on. So let's see. Today I will speak about anomalies in logic, and I think it's a way of. It's always interesting to try to have maybe a different perspective through this notion of anomaly, but how we can do that? What I want to say also is that nowadays, I mean, since these last years, there is a tendency among people doing philosophy of logic, but most of the time they are not logicians. There is a tendency to say that there is this word, no, which has been coined, also a word. I mean, we have to be very, how to say, very careful about this question of words. So there is a guy, he wrote a paper which is called anti-exceptionalism in logic. Logic is not exceptional. Well, and then what does it mean? And there is this word, exceptional. I think if I had a look of the paper because I know the guy and so on. So there is this tendency to say that logic is nothing different. It's like everything, you know. But what does it mean? And is it true? We have to think about that. And we will see this today, examining, studying this question of anomaly, to see if logic is like something, is like any kind of science. During many years, many centuries, logic was considered as something very special. It is still considered as something special. I don't see the point. And it's not based on any kind of interesting.
Okay, we can hear you. We cannot hear you, and we cannot see you. The microphone and the camera are off.
Yes, I think it's a problem of
with a way of speaking, and without, it's very superficial. And if you look what people are, if you look at the content of the paper, there is nothing, you know.
Okay, we can hear you and see you very well.
We can say also it's the same for me. Also, so I will speak Portuguese. For me, it's the same. You say, well, human beings are like any animals. Is it true? So there is a tendency to put. I think it's a kind of philosophical way of speaking. I don't know if it's philosophy, but ideological perspective. You say that everything is the same level. So human beings are like monkeys, you know, and something like that. But is it the case? I don't think I'm a monkey. You know? So there is this tendency to put everything to want to put everything at the same level. And people say, well, logic is not something different. And see. But let's see. Today, in this, can you hear me? Yeah?
Yes, very clear. We can hear you.
So, I will today in this talk, I will try to show that it's not the case. That logic is not like any kind of science. It's very easy to see that. You know? So let's.
Okay, we cannot hear you.
You cannot hear me. Okay. That is irrational.
It's not the mic.
Okay, maybe it's a problem with your connection.
Sometimes frozen. Mic is working fine. We can.
maybe.
This device connected, so
Okay. Anyway, I will go on. So there was this proof that the square root of 2 is irrational. Okay. So in some sense, we can. Can you hear me?
Yes, we can hear you.
I think we can.
Okay. So the proof that square root of 2 is irrational. It's an anomaly if we want to use this, because the people from the school of Pythagoras, they had the idea that everything can be explained by what we call nowadays natural numbers without zero, and that was fundamental for them. They had this kind of idea that everything can be explained by natural numbers and relation between them, which nowadays we call rational numbers. Then someone of the school of Pythagoras proved that square root of 2, which is a simple concept that everybody can understand, yeah, is not rational. So that's why very surprise among people of Pythagoras. And it's interesting because the idea, for example, why people of this group of Pythagoras, why they had the idea that everything is natural number. It was kind of a dogma, if we can use this word. No? And then by reasoning, and this is where logic is important, by reasoning, it was proved that it is not the case. There was a proof showing that some very simple mathematical number is not rational. So the logic at this point is very important because it's something that you cannot do anything against that. There is a quote which is attributed to Einstein. We don't know. I don't know. We will have to check if it's really due to Einstein, because sometimes many people they put a quote and we don't know exactly. But there is a famous quote by Einstein. It's like that. With logic, you go from A to B, and with imagination, you go everywhere. I think this quote does not make sense, because as we can see here, this is not with imagination that we go everywhere. It's with logic. So the idea of logic is not to go from A to B, because with logic you discover new things. Yeah. But as I'm saying, I'm not sure that this quote was really from Einstein, but it's generally attributed to him. But it's not a right idea about reasoning, because with reasoning we go everywhere, and more like that. We go in a place where we didn't even think this, we didn't even thought that this place was existing. So logic is taking us in different place, place we even didn't imagine. How can you imagine square root of 2? So logic is much more than imagination. It's important to know that. And of square root of 2 is considered by some people like Dieudonné as really the birth of mathematics. He wrote a book which is called in English Mathematics, the Music of Reason, saying that he says this proof is a birth of mathematics. So it's quite interesting to see how logic, in this case, takes us to something different, which can be considered as an anomaly because it was not expected. It was something surprising, different, and so on. But very important for the understanding, for the development of mathematics, and also for the application of mathematics to reality. Now, I would like to speak. I'm talking about this example, but in mathematics we have many different examples like that. For example, if we think about the proof of Cantor that the real numbers are not denumerable, something similar, you know, because the idea of infinity is something very fuzzy and so on. But Cantor, he succeeded using logic to prove that there are different kinds of infinity. Also something very surprising that we can consider as an anomaly. And I think these kind of things are much more interesting than the so-called paradox. Because paradox, we don't know exactly if it's really interesting. You know, people will spend I don't know how many times, how many books and so forth have been written about the liar paradox, but this leads nowhere. No, there is no very interesting things that people are saying about that. I'm not saying that this paradox is not interesting, but you spend all your life on the liar paradox and then you die. Okay, and what's that? Now, if you do something like this results with Cantor or with the proof of irrationality of square root of 2, that's really a good progress for the understanding of science, for the development of mathematics, and for the understanding of reality. Because as we know, the mathematics is very important for all science in physics and so on, as we know with theory of relativity, non-Euclidean geometry, and so on. So you can understand reality by reasoning, and reasoning, which is something which is most of the time surprising, and we can call this an anomaly. Okay, now I would like to speak in the second part of my talk to something a bit different. So nowadays, when we are talking about logic, in modern logic, we have the main system. There are many different systems of logic, but the main system is classical proposal logic. And then we have first order logic, we have non-classical logic, and so on. Now let's see this logic, what it is. So logic, as I was saying, I was discussing at the beginning of my talk, logic is different from other fields. Why? Because we are doing in logic, so logic, there are two different understanding of this word. So logic is at the same time the reasoning itself and the study of reasoning. This way of speaking also takes place in history, because when we are talking about history, there is history which is a big H, which are the events, and history as a science. Sometimes people talking about historical science, something like that. But the word, people are using the same word. Well, in logic, the same. We use the same word for talking about reasoning and the study of reasoning. There is good reason. There are some good reasons to do that, but also it generates a lot of confusion. Because if you say to someone, so what is logic? You know, say classical proposal logic. Well, classical proposal logic, like syllogistic, is a system which is supposed to describe the way that we are reasoning. Yeah, well, it's a theory, and is it right, wrong? Well, it's like any from this point of view, it's like any scientific theory. Yeah, it's something that is not catching the whole reality. Yeah, it's not catching the whole reality. It's working up to certain points, and we have to be aware of that. Catching up to a certain point. And but there is a difference in logic between logic and let's say physics. Why? Because we make this distinction between something which is descriptive or normative. And this is a discussion since the beginning of the history of logic as a science with Aristotle. You know, Aristotle, he say, well, we have to reject false way of reasoning, and he wrote a big book about that, about sophistic reasoning. And then we have to follow some rules, which are the good way of reasoning. So it's something which is normative in this sense. In physics, physics is not normative because why? You want to describe reality as it is. So there is a difference from this point of view between logic and natural science, because we are reasoning. Yes. What do we want to do? Do we want to describe the natural reasoning, or do we want to develop a new way of reasoning, a better way of reasoning? Yes. There is no reason to think that the usual way of reasoning is good. Because the usual way of reasoning is a mess. Everybody knows that. Most of the people make confusion all the time. So Aristotle was right. You know, we have to do something to improve our way of reasoning. Now, can we say that classical propositional logic do that? That's very dubious. You know. So classical propositional logic is a nice system from the point of view of mathematics, but can we say that it is describing natural reasoning, describing, and so is it a good norm to perform reasoning? Oh, there are a lot of discussion about that. I mean, not that I'm saying a lot of discussion. No, I think there is not enough discussion about that. Well, because we are here in the Department of Philosophy, and it's the same in different places of the world, and people teach classical propositional logic. Maybe it will go like 200, maybe it will go like that during 2,000 years, like it was done with syllogistic. And this is completely without meaning, because, and by the way, this is one of the reasons people reject logic. So I am trying to defend logic in the philosophy department, but I think that people are right not to accept that, because what are you doing with that? It's a bit of mathematics. It's a bit of something like that. It doesn't give you any understanding. You make a truth table. And so what? What will you do with your truth table? Is it important in your life for doing philosophy? It's very confusing. So mathematicians don't like logic. Philosophers don't like logic. So we have to think about that. Yeah. And I think they are right. They don't like because logic is not presenting in a good way. It's not presented in a good way. Logic can be very interesting, but you cannot just teach classical propositional logic. And people, they present most of the time. People say something like that. They say, "Well, classical propositional logic is something very trivial and so on. Let's go to first order logic and so on." But classical propositional logic is not trivial at all. If you think from the mathematical point of view, it's a system which is quite complex. And also the problem is that people are not making connection between the system and what it is supposed to describe. So now what I want, yeah. Okay, 5 minutes, okay. So people are not aware of many different strange things that we can call anomalies that appear in classical propositional logic. So I will give you an example here. And I would like to know if anybody, or after that, we will make a sondage, if people already knew about that. So in classical propositional logic, there is something which is a bit strange. So you take three propositions, P, Q, R. Not atomic proposition, any kind of proposition, yeah. And then what do we have? We have a tautology, which is like that. P is equivalent to Q, yes, ou P is equivalent to R, U Q is equivalent to R. If you take an example, it means like if you have a triangle, a square, and a circle, two of them are equivalent. That's classical propositional logic. And few people are aware of this anomaly. How can you explain that? Let's see if you have an explanation. But this is, we can, in some sense, this is a big defect of classical propositional logic, and which has kind of explanation, but this is a situation. So this kind of reasoning does not correspond to reality of reasoning or science or something like that. No, I think that classical propositional logic is a nice system from the mathematical point of view. Now, if you see exactly how it describes reasoning, does not really. People say, well, let's do some non-classical logic. But I don't know any, up to now, I don't know any good non-classical logic. Most of them are variation of non-classical logic. They are not from the mathematical point of view. They are very weak. They have a lot of defects. So I think the science of logic is a completely open field. There are many things that we can do for improving this science. But you see, this is an anomaly. No? And I think few people know about this. Let's see. Okay, thank you.